Hi, in this video, we will apply the unsupervised learning technique called clustering to the Old Faithful dataset stored in faithful.csv. We will use the data values in the eruptions and waiting columns to predict whether the next eruption will occur. Let's read this data into our program and extract these two columns. Next, we need to standardize the data using the standard scalar. As a reminder, standardization is useful when your data has varying scales and you need to normalize the distribution of the data for analysis. Now that we're done scaling the data, we apply the Kmeans algorithm by specifying the number of clusters, and then create a model by creating a Kmeans object fitted with the scaled data above. When plotted, the dataset shows 2 clusters, therefore we should set k equal to 2. To create a Kmeans model, we write the following. The Kmeans object constructor takes an argument for the number of clusters, and then we fit it using our standardized data. From the Kmeans model, we can now get the centroids by writing the following. Let's print the variable centroids to see what it's storing. In the console, you'll see that it returns a 2D array of the x and y values of each centroid. We have 2 pairs of xy coordinates because we have 2 cluster centers. Let's also get values for the cluster labels. Because we have 2 clusters, the model will label the data either 0 or 1. To get the labels, we write the following. Let's print labels to see the outcome in the console. As you can see, the labels are either 0 or 1. If I were to change k to a higher number, like 4, it would label the data 0, 1, 2, or 3. Let's try it. Cool. Okay, let's change k back to 2. Okay, now that we have our centroids and labels, let's plot this on a scatter plot. Let's set the size of the scatter plot to 5 by 4 inches. Next, we need to plot each data point by cluster using a for loop. We can use the range of k, which is our number of clusters. In each iteration of the loop, we start by getting all of the data for one cluster, doing the following code. If I was 0, this code will return all data points that were labeled 0, which is the first cluster. On the second iteration of the loop, I will be 1, and therefore it will get all of the data points labeled 1, which is our second cluster. Next, we need to plot these data points. We need to plot all of the x values, or the data in column 0. We also need to plot the y values, or the values in column 1. Let's label the axes of the graph and call the show method to see how this looks so far. When I run the code, this is what is produced. Let's add the centroids to this graph. Remember, when we printed centroids, it was storing a 2D array of x and y coordinates, so we can use the same indexing technique to get all the x values by writing, and all of the y values by writing. The scatter method also allows us to specify the marker, size, color, and label for the centroids as well. Let's customize it. Great work! Remember, while Kmeans doesn't work for every dataset, it does work for some, like the Old Faithful dataset. Now it's your turn to explore this example.